tomorrow will be better. Solve for x and the equation this. Please, before you scroll up, hold on. Most of you look at these exponential equations and get frightened at first sight because it appears lengthy or whatever is frightening you, I really don't know. But like I told you before, most of these mathematical equations that appear so frightful usually turn out the simplest of equations you can find. This is an exponential equation in one variable and we are asked to find x. Follow me, dear friends. Solution. Let's start by rewriting this equation. 6 to the power of x minus 2 to the power of x equals to 2 to the power of x plus 1 minus 6 to the power of x plus 1 and then plus 2 to the power of x plus 2. The secret for exponential or in exponential equations is your good mastery of indices and logarithm. If you master these topics, this is the key to succeeding in exponential equations. Now, to solve this, it's very important to bring all the terms or most of the terms to a common base, all right? And at first sight, if you look at it, you will notice that the simplest base here is 2. And fortunately for us, there's a way of expressing or extracting 2 from 6. Again, we will do this using the laws of indices and logarithm. I will start with 6. But this is the law which I'm about to use. 6, which I see here, can be written again as 3 times 2. Now, there was an exponent already, which is x. Now, in accordance with one law of indices and logarithm of indices that says a times b, all x should be equal to a to the power x times b to the power of x. If you remember this, then we are going to quickly apply it here and obtain that 6 to the power of x will boil down to 3 to the power of x times 2 to the power of x. Okay, now this is already done, and here we will just share the powers because again the law says a to the power of n plus n is the same as a to the n times a to the n. Bro, this is inevitable. Indices is inevitable in exponential equations. Okay, so you really need it. So this 2 to the power of x plus 1 will boil down to 2 times 2 to the power of x. 2 to the power of 1 is just 2, so that is it. And then where else here? 2 to the power of x plus 2 once more will be 2 to the power of x times 2 to the power of 2. Of course, 2 to the power of 2 is 4. Now, with this in mind, I'm going to replace each of these terms by their simplified version. So, I start with this. So, here I'm going to have that 3 to the power of x times 2 to the power of x, now minus 2 to the power of x should equal, now I'll have here 2 to the power of 1 times 2 to the power of x minus the same thing we did here is the same thing we will do here right now. So we will have 3 to the power of x plus 1 into 2 to the power of x plus 1. I'm just sharing because 6 to the power of x plus 1 is the same as what we did here, right? Just that here the exponent is no longer x but now x plus 1. And then finally here I'm going to have that 2 to the power of 2 like I had down here times 2 to the power of x. All I have to do right now, dear friends, is to simplify my expression. You have to be very careful to avoid making mistakes as far as simplification is concerned. Now, look at what I'm going to do here. I'll start by bringing what looks like terms together, okay? So, see what I have here? X times 2 to the power of x. I'm going to leave this term here alone. Now, look at this other similar term here. That has 3 to the power of something and then 2 to the power of something. So I'll bring all of this bulk to this side. But be careful here. Something is going to happen. The first thing that will happen here is a change in sign. Okay? From negative, it becomes positive. Now, I want to break down this thing in accordance with this formula here. Something to the power of x plus 1 is, we break it down as follows, and that's what I'm about to do here. But I'll first open a big bracket as so. So 3 to the power of x plus 1 is the same as 3 to the power of x times 3 to the power of 1. This is the same thing here. 2 to the power of x plus 1 is 2 to the power of 1 times 2 to the power of x. So 3 to the power of x plus 1 is the same as 3 to the power of x times 3 to the power of 1. And be careful, there is now times 2 to the power of x plus 1, which is just it here, will be 2 to the power of 1 times 2 to the power of x. Be very careful not to make mistakes. Okay, I'm done expanding this term. Permit the expression expansion, though it's really not expansion. Okay, so, and I brought this to this side. This will be equal to, this was to the left, now I take it to the right, and it becomes positive 2 to the power of x. Now, what does it meet here on the right already? There was this term on the right already, so plus 2 to the power of 1 times 2 to the power of x. This is one of the things that was already to the right, and now this one too was already on the right, but I'm about to simplify it further, and instead of 2 to the power of 2, I will have 4. All right, so 4 times 2 to the power of x. Good. We will continue the simplification process as follows, this time around with some more attention, because things are getting a little bit more complicated because we have so many things to handle at the same time. Look at this. I'll start by writing this first like this to the power of x. See what's going to happen here, dear friends. 3 to the power of x will remain, and then 2 to the power of x will also remain. But look at this. These are two scalars that have no power, no indices, or no unknown indices. We have 3 to the 1 and 2 to the 1. This is simply 3 times 2, and which is 6, which all of us know to be 6. Okay, sometimes in trying to be careful, we think too much and we miss the point. There's really nothing to think too much here. This is 3 to the power of 1 times 3 to the power of 2, which is 6. Okay, so I'm going to say this is 6. All right, if this is 6, it means I have 6 times 3 to the power of x times 3 to the power of 2. So plus 6 times 3 to the power of x times 2 to the power of x. Okay, now I'm done with the left side. I move to the right side. See what is going to happen on the right side here. If I take 2 to the power of x to be a certain another variable, maybe a, this means I'll have 1a plus 2a plus 4a, giving me 7a. Okay, dear friends, giving me 7a, 7 times a. All right, now look at this other side of the equation. If 3 to the power of x times 2 to the power of x were another variable, maybe y, it means I will have 1y plus 6y, which gives me 7y. Okay, so this should be equal to 7 2 to the power of x. Notice some things that are going to fall off here. 7 cancels 7 here by the law of division. 2 to the power of x cancels 2 to the power of x here, still by the law of division. In conclusion, you are left on the right, on the left side with 3 to the power of x, and on the left side with just 1. Dear friends, in accordance with the law of indices, this same 1 here is the same as 3 to the power of 0. Why? Because there's nothing we can do here unless the bases are the same. And once the bases are the same, we now focus on their indices. And if 3 to the power of x equals to 3 to the power of 0, therefore x is equal to 0. This is how simple and beautiful it is, because tomorrow will be better.